Madam, voice వినిపిస్తుందా మేడం? Hello, my voice is clear, madam?
Okay, sir.
Okay, thank you, madam. Thank you. Good afternoon, wonderful participants. Today is the final session, that is the day 6. Today final session, warm greetings from Narsimha Engineering College, Hyderabad, School of Computer Science. We cordially invite to join us day 6 and final day on 1 week online faculty development programming on emerging tools, techniques in cloud computing and data types. Talk by eminent experts. Today resource person, Dr. K. Shanti Madam, introduced by the Hanisma Madam.
Good afternoon to the resource person and wonderful participants. Dr. K. Shanti ma'am, who completed her PhD in Big Data and Machine Learning from Sri Venkateswara University, completed her MTech in Computer Science and Engineering, JNTU, Hyderabad. With over 18 years of experience, she has been awarded as National Excellent Educationalist Icon 2023. Gurudeva Bhava National Award, Best Teacher Award, Dedicated Educator, specializing in advanced topics such as deep learning, machine learning, artificial intelligence, big data analytics, data warehousing, Python, and more. Not only this, ma'am is also well versed in academic procedures and practical sessions for numerous students. Her remarkable research output includes 20 publications, patents, elsewhere, conferences, authored books, also gained many certifications from NPTEL and Udemy in specializations. Thank you.
Madam, can you stop my staring, madam? Hello? Madam? Hello? Madam, my voice is clear?
Yes, sir. Voice is clear.
Okay, sir. Okay.
Sir, good afternoon to one and all. This is Dr. K. Shanti, Head of the Department of the SV College of Engineering, Tirupati. Today we are going to uh, present a session on machine learning and data analytics. So before starting up the session, sir, is the screen visible, sir?
Check. Oh, no, madam. 1 second. One minute, please. No. Madam, yes, madam. Your screen is visible, madam.
Okay, so we'll start this session, sir. So we'll start this session with the data analytics. And so before going for the analytics, the purpose of the analysis is analytics is for first after having the large data sets, why we have to go for the data pre-processing. The intention is for after extracting the large data sets, we are going to have the patterns which we have to identify there. So from the large data sets, we have to examine it and we have to extract the similar patterns of it, and we have to go for, in order to extract the similar patterns, we have to go for data pre-processing and analyzing the data, as well visualizing the data. So for that purpose, we are going for the data analytics part here. So we the concept of this data analytics is we have to go for a process of examining the large volumes of the data, so to uncover the meaningful patterns from it, right? So under this analytics part, we are having various steps involved. We are going for data collection and cleaning, as well exploring the data, as well as statistical analysis, and finally a predictive modeling as well. So here the intention is, after collecting the data, after going for the pre-processing, here we are going to implement, we are going to use the data for particular output. Either we are going to predict some class labels for it. So that's the reason why we are just going to call that as a predictive modeling here. So now coming to the predictive modeling here, we can so machine learning algorithms are, we are going to, if you are using the going for a machine learning algorithms, we are going to go for regression, as well classification, clustering, as well time series analysis. So these all comes under a particular category which you are going to call it as a predictive modeling here. So here, after going for data analytics, we are going to use the data for executing the learning algorithms for various purposes. That may be based upon the output what you want. We are going to choose any one of the learning algorithm. That may be either regression or classification or clustering. So based upon the class label, if the class label is of character data type, we will be preferring the classification. As well, if our data type is if you are going to go for the numeric value, finding out of numeric value, then we'll be going for a regression concept as well. So likewise, if you want the if you want to go for grouping or clustering, means we'll be just preferring the clustering algorithms as well. If you are implementing the time series purpose processing of time series data, then we'll be going for time series analysis. Like nowadays, we are going for a EEG data set. We are implementing time series data set on which we are going to make use of machine learning algorithms. So here uh, we are we are going for predictive modeling only after completion of your data analytics part, right? So that predictive modeling also comes based upon the output what you want. So based upon the output, we are going to select a particular data machine learning uh, algorithms. So that's the thing. And now coming to, so this is what we have discussed. So after having the data analytics, we are going to go for, based upon the what sort of output you want, you are going to make use of learning algorithms. So now coming to the clustering part. Clustering is basically a unsupervised learning, and we also know that we are going to make use of different algorithms available in order to perform the clustering as well. And especially we are going to go for k-means, k-minad likewise. So as well, we can also use clustering as a standalone tool also for marketing and risk analysis purpose, and in the real estate sector as well. Uh, Under this clustering, we are having various categories of algorithms. We are having the partitioning algorithm as well. We are going to go for under which we are having the k-means and k-minad. As well, we are going to have hierarchical clustering algorithms, under which we are having the divisive and agglomerative algorithms. And under likewise, we are having the next category as density based clustering algorithms, right? So based upon dense, okay, how far the data is dense, we are going to go for the density based clustering algorithm as well. And that's what that is a brief introduction towards the clustering. And this is the example of going for a clustering k-means algorithm. So by which you are going to go for uh, implement the k-means, and here we are going to identify the center point of some of the data instances, and we are going to by default we are going to take some one data instances as a center point, and we are going to roughly you are going to make the clusters of it, right? And after performing the after having the clusters, right, we are going to find out the distance from the center point, which you are going to call it as a centroid, and you are going to find the distance from this. If the distance is greater than the threshold value, you are going to eliminate a particular point from this particular cluster. So if distance between the centroid and this particular data point is somewhat less, then we are going to consider this is the part of the clusters. So likewise, initially in the first step, you are going to identify the center point, which centroid, and you are going to find the distance from center point to all the data instances within a cluster, right? So if the distance between the centroid and the data instances is more, you are going to eliminate that particular data instances from the cluster, and we are going to in the second likewise you are going to calculate the distance from this particular centroid and to all the data instances in this particular cluster. If that in the likewise, if the distance is more, you are going to eliminate those particular data instances. And after eliminating, you are going to have you are going to have uh, one more cluster here, which will be formed, right? And after having those cluster, okay, data points within the cluster, and we are going to once again you are going to calculate the mean of these data points in the cluster. So if you are calculating the mean of these data instances or data points in the cluster, obviously there will be a change in the centroid, right? So if you are by default, if we are identifying this as a centroid, right, I as a centroid, from the I you are going to calculate the distance from I to B and I to C, right? So if these distances are less than the threshold, obviously in the third step also you are going to consider this is going to be the final cluster, right? That's the logic behind this k-means algorithm, which comes under partition based algorithm here. So likewise in the hierarchical also we are having the two types of uh, algorithm, which is a divisive and agglomerative, right? So this hierarchically algorithms basically comes from actually grouping of the data. It aims at grouping of the data from the individual data, right? So initially, if you are going for hierarchical clustering here. So initially, if you are going, either we can either go for divisive or agglomerative, right? So actually, initially we are going to have the group of the data, and based upon the similarity, we are going to divide a single group into two groups. And if there is some dissimilarity, again we are going to divide that particular group into variant groups. So, or else other categories initially will be having a single instance, single data, and you're going to, if they are, you're going to have individual data, and you are going to group the data based upon the similarity. Likewise, we are going to group the data. Finally, we are going to have the single group of data. So, and next category, what you have is a density-based clustering, and under which you are going to have, which is unsupervised machine learning. And in the density-based, we are having some features which we are going to focus on the local density, So here the idea of local density forms the basis of the density-based clustering, which refers to the number of data points within a specified radius of a given data point. And as well, we are going to go for the second key concept, which we are going to call it as a core point or a data points with a minimum number of neighboring points within the specified radius. And moreover, this database density-based clustering algorithm considers core points as a part of a cluster, and it follows a chain of neighboring points to connect other points to them. And we are going to go for the third key point, which you are going to call it as a border points. And border points are the data points that are not core points but can be connected to the core point by following a chain of neighboring points. So these border points are considered as a part of the same cluster as a core points to which they are connected. As well, we are going to focus on the noise or outliers in this particular algorithm. So points that do not belong to any cluster, right? After performing the cluster, if data points or instances which are not belonging to any cluster and have no neighboring points, so they within a specified radius are considered as noise or outliers here. Likewise, another key point here is we have epsilon parameter. We use the epsilon parameter to determine the maximum distance uh, between two data points considered the part of a same cluster. So epsilon defines the neighborhood of a data point, typically set by the user based upon density of the data set and the desired cluster size. And uh, so next key point, what a density based algorithm is focusing is minimum points parameter. So this will be considered as a part of the cluster, a core point, which core point must have at the very least and minimum number of data points within its neighboring specified by the minimum points parameter. And this parameter, minimum points parameter, helps to filter out the noise and distinguish between core and border points. As well, the last key point, what we are going to focus on the density-based clustering is density reachable points. This density reachable points are data points that are not core points but can still be reached by following a path of neighboring core points within the specified radius. So these points are essentially in expanding the clusters and determining their shape and size, right? And that's a thing about density based. And now coming to grid based here. Uh, so this is data space is partitioned into uh, finite number of cells in the grid based, and moreover, grid based is technique is very small, very fast, and we can with low computational complexity, we can go for grid-based technique. As well, we are going to have the next type is uh, model-based, and here, just one moment, one second. Coming to model-based, where there are number of model-based machine learning algorithms. We are having we will be preferring the model-based algorithm based upon if you want to generate a custom solution for a particular challenge, then we'll be preferring. And so here under model-based algorithm, we are going to make use of the purpose of this is we are going to have offer a single development framework that facilitates the building of diverse variety of custom models. That is the intention here, and this particular paradigm is evolved as a result of significant confluence of three main ideas here. So we either factor graphs or based on perspective or probabilistic programming. So that is about model-based algorithm. And now coming to constraint based here, uh, this constraint based algorithms find the cluster that identifies the user stated preferences or constraints here. So there are several categories of constraints. So the category constraints on the individual objects, and it can define the constraints on the objects to be clustered. In a real estate application, for instance, one can like to spatially cluster only those luxury mansions worth over $1 million. This constraint confines the collection of objects to be clustered. It is simply be managed by pre-processing, after which the problem decreases to an example of unconstrained clustering. And now coming to the constraints on the selection of the clustering parameters. Here, a user can like to set a desired area for each clustering parameter. Clustering parameters are generally quite specific to the uh, given clustering algorithm. So example of these parameters contain k, the desired number of clusters in a k-means algorithm, or the radius, or and median number of points in DB-scan algorithm. So that is the constraints on the selection of the clustering parameters. And now coming to the constraints on the distance or similarity function, it can define several distances or similarity functions for definite attributes of the objects to be clustered, or different distance measures for limited pairs of the objects. So that is the thing. And now coming to the next, that is user specified constraints. So user can like to specify the desired features of the resulting clusters, which can strongly hold the clustering process. So that is the thing here. And now constraints based algorithm has several advantages regarding the flexibility as well, consistency, optimality, reusability, as well transparency. So finally, it's a more flexible, consistent, and optimal algorithm. And now coming to the next part, that is outlier analysis algorithm. Here, basically, before going for this, outlier is a data point or data instance that significantly deviates or differentiates from the rest of the data points. That is the outlier here. And um, the analysis of outlier data is referred as outlier analysis, and we are having two main types of outliers, which we are going to call it as a global outliers and contextual outliers. So global outliers are isolated data points that are far away from the main body of the data, and they are often easy to identify and remove. And coming to contextual outliers, This are also a data points. These outliers are also a data points that are unusual in a specific context, but may not be an outlier in different context. So, in a particular context or a particular thing, you will be calling it is different, but may not be differentiable in some other context that will be calling it as a context outlier. So it's about different types of outliers we are having. And now coming to the outlier detection methods in machine learning. So here you are um, going you are going to have different outlier detection methods in machine learning. First type is going to be the statistical methods. Statistical methods under which we are going to make use of z-square. This z-square method calculates the standard deviation of the data.
దీనికి ఇంక నేను చేయలేక చచ్చిపోతున్నాను.
So z
Sorry, madam. Sorry for the disturbance. Okay, please go ahead, madam.
So this now, while we are discussing about the outlier detection methods in machine learning, we are having the first outlier detection method, which is a statistical methods. Under statistical, we are having the z-square method, and this z-square method calculates the standard deviation of the data points and identifies the outlier from those z-squares which are exceeding this certain threshold value. So that is the thing under Z square, and under statistical we have another thing, that is a method which is interquartile range, which you are going to call it as IQR, right? So this IQR identifies an outlier as a data points falling outside the range, right? Outside the range. If the outliers are falling outside, then we will be using the outlier IQR statistical methods for identifying the outlier. And now we'll discuss about the distance-based methods for detecting the outliers, under which we are going to have the first method under distance-based is K nearest neighbors, or KNM, which is meant for which identifies outliers as the data points whose K nearest neighbor are far away from them, right? So based upon the distance, we are going to find the outliers. We are going to detect as an outlier which are far away from the group of data instances or data points. That is K nearest neighbors. And under the distance based, we are having the second method, which you are going to call it as a local outlier factor, or that is LOF. And this LOF is a method calculates the local density of data points and identify the outliers as those which significantly lower the density neighbors compared to their neighbors. Okay, so that comes under data-based methods. And now coming to the cluster-based methods for identifying the outliers, we are having DB scan, uh, which is going to which clusters the data points based upon the density, and and identifies the outliers as a point not belonging to the cluster. So that is the DB scan algorithm, which comes under cluster-based method. And as well under cluster based, we have one more thing, that is going to be the hierarchical clustering, which involves building a hierarchy of clusters by rotatively merging or splitting the clusters based upon their similarity. So we already discussed under this cluster based under hierarchical based clustering algorithms, we have gone for agglomerative and divisive algorithms under hierarchical. So the same pattern you are going to follow under this hierarchical clustering method for identifying either agglomerative or divisive algorithms to identify the outliers. So that is what about the outlier analysis algorithm for detecting the outliers here, right? And you have in spite of this we have techniques for handling the outliers in the machine learning, and we have the first technique is identifying and removing the outliers from the data set before training the model, right? And first is going to be, which you are going to call it as removal, right? Which we are going to identify. Initially you are going to identify the outlier and remove the outlier from the data set. And second technique is transformation, and this involves transforming the data to reduce the influence of the outlier, right? So that is under this transformation you are going to have the scaling and visualization and long transformation. And as well, we have one more another technique that which you want robust estimation, and this involves using the algorithms that are less sensitive to outliers. So this robust estimation under this, which we will use a robust regression and M estimators, as well outlier insensitive clustering algorithms. Right. So we have a number of techniques for identifying the outliers, and now coming to the next part of the session, that is going to be the cohort analysis. This is going to be a valid tool for anyone looking to gain a deeper understanding of their customers and why they make certain choices in our app. So the major advantages of conducting the cohort analysis is for uh, determining the business health, and so determining in the sense business health in the sense is a greater indicator of the healthy business, while increasing the revenue if we are acquiring new customers. And another benefit of this is understanding the customers better, right? And with cohort analysis allows the businesses to gain a deeper understanding of the customers by tracking their behavior over the period of time. As well, we can also another benefit is enhancing the customer segmentation, that by dividing the user groups and creating the specific cohorts businesses. Uh, that is the thing. And next is for increasing the customer retention, right? And optimizing our app for interested increase interest. So that is another topic. And now coming to the regression analysis, and this is a statistical method which shows the relationship between two or more variables. Usually, this regression is expressed in a graph. As we see in the mathematics, we are having the linear regression as multiple regression, in which we so that this method tests the relationship between the dependent variable against the independent variable. Typically, the dependent variables change with independent variables changes with the dependent variables, and the regression analysis attempts to answer which factors must matter most to that particular change, right? And the example of regression analysis, if we just talk about uh, a situation where if you just go for retail business, which needs to predict the sales, or else if you just go for estimating the budget of the house, which is the output or a class label, And this budget of the house just depends upon the location of the house as well the square feet area of the house. So, so in order to calculate the budget of the house, we are going to finally depend upon the location as well the square feet of the house. So that is the real world example of the regression analysis as well. Uh, uh, Now coming to the neural networks. So, so this neural networks is a machine learning model which is mimicking the functionality or of a human brain, and this has also been referred as artificial neural networks or networks. It represent a type of deep learning technique that's classified under a broader field of artificial intelligence. And and this neural networks are widely used in various applications, including image recognition and predictive modeling and natural language processing. And now coming to how this neural networks works. So artificial neural networks usually involves many processes operating in a parallel or arranged in tiers or layers. The first tier analogous to the optic nerves in a human visual processing receives a raw input information, and each successive task receives the output from the tire preceding, and it rather the raw input. The same way the neurons further from the optic nerve receive signals from their closer to it, and as well the last tire produces the output of the system. So each processing node has its own small sphere of knowledge, including what it has seen and any rule it was originally programmed with or developed for itself. So the tiers are highly connected, and which means each node in a tier n will be connected to many nodes in tier n minus one its inputs, and in tier n minus one, which provides input for those nodes. So there would be one or more nodes in the outer layer from which the answer it produces can be read. So, and artificial neural networks is being noted as an adaptive network, and which means to modify themselves as they learn from initial training, and subsequent runs provide more information about the world. So, and actually, the most basic learning model is centered on weighting the input streams, which is how each node measures the importance of input data from each of its predecessors. The inputs that contribute to getting the right answers are weighted higher. So now coming to the applications of the uh, artificial neural networks, we have the chat boxes, NLP, as well drug discovery and development, social media, personal assistance as well. So it's the brief introduction to the neural networks. And now coming to different types of neural networks here, you are we are going to have the feed forward neural network, and this is going to be the most simplest variants of the neural networks that pass information in one direction through various inputs until it makes it to the output node. The network might or may not have hidden more layers, making their functioning more interpretable. It's prepared to process large amount of noise. And coming to the second, that is a recurrent neural networks, and this RNN saves the output of processing node and feed the result back into the model. This is how the model uh, learns to predict the outcome of the layer. Each node in the RNN model acts as a uh, memory cell, continuing the computation and execution of the operations. So this neural network starts with the same front propagation as a feed-forward network, but then goes on to remember all processing information to reuse it in the future. So that's the RNN. And next, coming to the convolutional neural network, and this is going to be the most popular models used today. This computational model uses a variation of the multi-layer perceptrons and contains one or more convolutional layers that can be either entirely connected or cooled. These convolutional networks create feature maps that record a region of the image that's ultimately broken into rectangles or set out for nonlinear processing. And that's about the convolutional networks. And next, coming to deconvolutional neural networks, and this use a reversed CNN model process. They try to find the last features or signals that may have originally been considered unimportant to the CNN system's task. This network model can be used in the image synthesis and analysis. And coming to the modular neural networks, these contain multiple neural networks working separately from one another. The network do not communicate or interfere with each other's activities during the computation process. So consequently, complex or big computation processes can be performed more efficiently. There's different types of neural networks. And now coming to the factor analysis. Factor analysis actually is a way to condense the data in many variables into just a few variables. So it also sometimes called dimension reduction. We can we can reduce the dimensions of our data. So the most common technique is known as PCA, that is principal component analysis, in which we are going to go for reducing the dimension vectors of the data points. So if data points are not lying on a particular area, you are going to calculate the covariance matrix, and from the covariance matrix, you are going to calculate the eigenvectors so that which lie on a single vector. So that's what we are going to see in the PCA. And so so now coming to the uh, how what is the purpose of how we can make use of the factor analysis. Now factor analysis can be useful in the uh, condensing the variables and as well for uncovering the cluster of the responses. So, okay.
Madam,
Sir.
your voice is not clear, madam.
Okay, sir. Just a moment, sir.
Oh, no problem, no issue. Participants, a small announcements within 10 minutes, 5 to 10 minutes, we will share the assessment link. Okay, within exactly 3:25 or 3:27. Okay.
So, stop the session, sir. There is some problem.
And no issue, no issue. Okay,
Okay,
okay.
sir.
Okay, madam. Wonderful. Okay. Participants, any queries? Within 2 to 3 minutes, we will share the link. Uh, Dear Madam, warm greeting from the Narsimha Engineering College, Madam. We are pleasure to highly appreciate your presentation and deliberation as a resource person for the today's FDP on emerging tools, techniques in cloud computing and data science, organized by the School of Computer Science in technical association with Computer Society of India, Hyderabad chapter. We would like to convey our sincere thanks and gratitude for your fruitful session on data analytics and machine learning. Your session is enriched and participants of the workshop will gain the knowledge and created the intellectual environment. We will feel honored to be collaborate with you in future also, madam. Thank you, madam.
Thank you very much for your.
Okay, madam. Dear
Yes, sir.
participants, okay, madam, you can leave, madam. Thank you.
Thank you, sir. Thank you.
Dear participants, today is the last day. We will close the session. Before closing the session, we need the participants' feedback from your side. Please, any one of the participants, please mute yourself and give the valuable feedback.